Well, hello there. All right, so last week we had our first in-person lab, and you guys performed 2 chemical reactions, and you hopefully noticed that if you can determine what the chemical equation is, if you can balance the equation, and if you can predict the correct products, then you can use that chemical equation to predict how much product you can get. All right, and what are the best ratios of your reactants to use in order to get the most product? All right, so we called that the mole ratios, and the mole ratios are given to us as coefficients in the chemical equation. This time, what we're going to be doing is we're going to be using our knowledge of how to balance equations, again, to find mole ratios. We're going to use that to do something new, which is we're going to be determining the actual quantities of products and reactants using those mole ratios. So let's see how that works. All right, so this is a warm-up to get us thinking about how we can do this. It says, this reaction produces the main substance found in human bones, calcium phosphate. The chemical equation reads that 3 calcium chlorides mixed together with 2 sodium phosphate in water produce calcium phosphate and 6 sodium chlorides in water. The calcium phosphate product is a solid. The question is, how many moles of calcium phosphate can you make using 3 moles of calcium chloride? The second question is, how many moles of calcium phosphate can you make using 6 moles of calcium chloride? Third, how many moles of calcium phosphate can you make using 111 grams of calcium chloride? So go ahead and take a few minutes to think about these questions and try to figure out the answers. Then, when you've had enough time, come back and we'll go over them. All right, so the first question is saying, how many moles of calcium phosphate, which is this product. All right, so if we have 3 moles of calcium chloride, that's this reactant over here, how many moles of calcium phosphate can you make? Calcium phosphate is this solid product over here. So we can see from the chemical equation that the coefficients in front are going to give you the mole ratio. So for every 3 calcium chlorides, you're going to produce 1 calcium phosphate. All right, so then that gives you 1 mole as your answer for how many moles of calcium phosphate you're going to make. The second question is, how many moles of calcium phosphate can you make using 6 moles of calcium chloride? So you can probably look at that and easily figure out that, mathematically in your head, you figure out it's like 2 moles. But I'm going to ask for you guys to actually use these ratios and set up a dimensional analysis using the mole ratios. So what does that look like? We're going to start with our given always. That's the 6 moles of calcium chloride. Set up times line, and then I'm going to put in the mole ratio. So what I want is to have the moles of calcium phosphate. So that goes on top, and there's 1 calcium phosphate for every 3 moles of calcium chloride. Writing in the moles to make sure I keep track of what units I'm talking about. I'm going to cancel out the moles of calcium chloride, and then I'll do the math part. 6 times 1 divided by 3 is going to equal to 2 moles of calcium phosphate. Make sure you write what your product is in your response, in your answer, and circle it. All right, so we have 2 moles that goes there. The last thing that we're looking for is how many moles of calcium phosphate can you make using 111 grams of calcium chloride. So we're given a mass this time instead of the mole. All right. So to do this part, I will start once again with my given. I'm going to do this one up here. So 111 grams of calcium chloride. Set up the dimensional analysis. And this time, since I'm trying to get to calcium phosphate, which once again, that's a different substance and we're dealing with grams to begin with, I'm going to have to first convert into moles of calcium chloride. So I'll set up that dimensional analysis by putting what I want, which is the mole. So 1 mole calcium chloride is to the number of grams of calcium chloride. And I just looked it up, and luckily, it is a very convenient number. It's 111 grams. Whoops. There it is. Okay, so we're going to cancel out the grams of calcium chloride, the grams. And 111 times 1 is 111 divided by 111, and that's going to give me 1 mole of calcium chloride. Okay, I'm still trying to get to calcium phosphate, and I want to know how many moles that is. So just like I did before, I'm going to use the mole ratio from the chemical equation to get there. So 1 mole of calcium chloride times line. I want calcium phosphate, and I know that that's 1 calcium phosphate mole to 3 moles calcium chloride. And the moles of calcium chloride will cancel out. 1 times 1 is 1. 1 divided by 3 is equal to 1/3. And so the answer for calcium phosphate is 1/3 moles. All right, so what we just saw here is that we're going to be using a lot of dimensional analysis, and when you're converting, you're always going to put the unit that you want on top over the unit that you have on the bottom. The second key point was that if we're converting between different substances that are in the reaction, we're going to use the mole in order to convert and in order to relate to those other substances that we're trying to figure out. We always have to use the mole for the conversion. All right. So this little cartoon is kind of cute. It's called the mole tunnel, and it's a nice way to just kind of remind us how to do this. So you have the mole that's in the center of the tunnel, and we call it the mole tunnel because in order for you to go from grams of some substance, okay, let's say a reactant A, and you want to know if you have, let's say, 15 grams of reactant A, you want to know how much product C that's going to get you in grams. So there's actually 3 steps that you're going to have to go through to do a problem like that. The first step over here is showing that if you have the grams of reactant A, you can't go directly to the grams of product C. You have to go through the moles because the chemical equation is relating all these species, all these chemical species through the moles, not through grams. So you're going to convert moles into grams, first thing. And you're going to use the molar mass in order to do that. Okay, so, sorry, the other way around. You're going to convert grams into moles. Once you have the moles, you're going to use the mole ratio, what we just saw, that's in the chemical equation in order to determine the moles of the product that you're interested in. And next, you're going to use the molar mass once again in order to determine what are the grams of the substance that you want, okay, to know. And so you have essentially 3 steps. Let's try one. Okay. All right, so read this problem and give this a try. See if you can use this example from the mole tunnel to make a calculation. It says how many grams of solid calcium phosphate can be made when 25 grams of dissolved calcium chloride are combined with excess aqueous sodium phosphate. All right, so a hint is start with your given. Okay, take a look. That's 25 grams of calcium chloride. Give it a shot and then come back to the video and see how you did. All right, so we're trying to figure out how many grams of solid calcium phosphate can be made. Okay, so I'm trying to figure out how much of this species can be made. And that's in grams that I'm looking for. So that's my unknown. I've given a reactant. I'm given the calcium chloride in grams. Okay, so that's my given, and I'm going to start there. So I'm going to go ahead and put down 25 grams of calcium chloride. And in order to get myself over to calcium phosphate, I have to go through the mole. So I'm going to convert the grams of calcium chloride into moles of calcium chloride. So I'm going to set up the dimensional analysis to do that. Okay, so I want 1 mole on top. That's of the calcium chloride. And that's over the grams of calcium chloride. Well, we just heard that calcium chloride has a molar mass of 111 grams. So I'm going to use that again. And so that allows me to cancel out the grams. I'm going to multiply 25 to 1, and then 25 divided by 111, that's going to give me my moles. All right, and when I do that, I ended up with 0.23 moles of calcium chloride. All right, so I want to convert to calcium phosphate moles. And so I'm going to use the mole ratio in the chemical equation to do that. So we've got 3 calcium chlorides for every 1 calcium phosphate. So I'm going to start with my given, which is the moles on the left. It's 0.23 calcium chloride moles. Okay, and I want calcium phosphate, so that goes on top, so that's a 1. To 3 calcium chlorides. All right, these are in moles. I'm going to write that down so I don't forget what I'm converting. My units are always really important. So I'm going to cancel out the moles of calcium chloride. 0.23 times 1 is 0.23 divided by 3. And I have, that's equal to 0.075 moles of my calcium phosphate. Okay, so not quite done because I still just have the moles, and the problem's asking for grams of solid calcium phosphate. So we have one more step to go. Okay, so my third step is starting with 0.075. Moles of now calcium phosphate, because I've converted to calcium phosphate in the last step. And now I'm converting to grams of calcium phosphate, so I want the grams on the top, 1 mole of calcium phosphate on the bottom. Okay, the molar mass of calcium phosphate is 310.6 0.2 is what I've got here. That's the grams. So 0.075 times 310.2 divided by 1. And so, oh, I forgot, canceling out the moles of calcium phosphate, and I'm going to get the grams. And I got 23 grams of the calcium phosphate. And there's my answer. All right, so now you're going to do the worksheet. It's called the mole tunnel. So give it a shot, some of these conversions, and remember to always go through the mole when you're converting between two different species that are giving you grams. And come on back here when you're done, and we'll do some quick checking in to make sure that the concepts are clear. So these are some follow-up questions to conceptually check in about this mole tunnel worksheet. So why don't you stop the video and read them, see if you understand these questions, and then we'll go over them, and you can restart the video for that. All right, so the first question was, what does the molar mass help you do in these calculations? And I hope that you saw in the example that we did together that the molar mass allows us to convert between quantities that are in grams to moles. And then from there, we're able to go between different substances that are in a chemical equation once we have the moles, using the mole ratios. All right, so the second question is, why can't you simply convert grams of a reactant into grams of a product? Well, remember that the chemical equation, the ratios that are given as their coefficients are not grams, not at all. They are volumes, they are moles, but they are definitely not going to be directly grams. And so we use the mole as a way to relate items that are in a chemical equation. So we have to go through the mole in order to actually convert to grams of a different substance that's in the chemical equation. All right, so when is it useful to consider mole ratios? It's useful to consider them if you are trying to determine how many moles of one of the substances are that you're going to be getting from a reaction happening if you're given a different mole quantity than what is actually in the chemical equation. So you use those ratios to do a simple conversion. All right, so the last question says, imagine that you want to know how much product you can make with a certain mass of a reactant. What is the first thing you should do? All right, so I hope that you wrote down that if you're given a certain mass of a reactant, that you're first going to have to convert into the moles of that specific reactant. All right, and then the next step would be to convert to the moles of the other substance you're trying to learn about. You're going to use the mole ratio to do that. Last step is going to be to convert from moles of the product that you're interested in into the grams of the product using the molar mass for that specific substance. All right, the last step, it just says describe the steps you went through in calculating how many grams of calcium chloride were needed to create 10 grams of calcium phosphate. So I'm going to let you do this one on your own, but if you're having any trouble, go back to the mole tunnel, to the image of the mole tunnel in the video, because I think that one's really helpful.